Hello everyone, this is Professor Fetterman, and in this review we're going to be taking a look at a review of chapters 12, 13, and 14. We start out the review though by going back to chapter 9 and realizing that everything depends upon the cost structure, and then we're going to take revenue and layer it on top of cost. So you have to know what these four different cost curves are: A, B, C, and D. From the top we've got marginal cost. Then we've got average total cost per unit, then average variable cost, and then finally fixed cost. And the critical point here is that average variable cost, what happens when you add another laborer to your manufacturing plant? Initially, average variable cost, the yellow line, comes down as you get more efficient, but at the point where it bottoms out and then it starts to go up again, that's where you see diminishing marginal productivity. So the cost structure comes from productivity. Surely on the quiz, I think these you're going to have to know these four different graphs of costs. In chapter 10, we talked about pure competition. Right? The industry on the right-hand side determines the price of the object or whatever we're selling, we're supplying demand meet. Then a single firm sees a flat demand curve. That is marginal revenue. Every time you sell another one, you get the market price, whatever it is. Now you take your cost structure and you layer it on top, and here you see the marginal cost curve, and where's the optimal production? Optimal production is always going to be where marginal cost and marginal revenue meet, and you should understand why. But we still don't know if we're making a profit, so let's take a look at the average total cost curve that I'm bringing in. So the quantity we're going to produce for this firm, the best they can do is going to be this quantity. But for this person, the average total cost per unit, which is from the average total cost curve, is above the price that they're getting, so they're going to lose money. What's going to happen when that happens? The supply is going to get smaller because someone's going to go out of business. The price will then eventually rise to just touch the average total cost, and that's the long-run adjustment process for pure competition. Now we take a look at monopoly and what the difference is. So if you want to hit pause and read the bullet points here, go ahead. Monopoly. Again, I'm not going to read these to you. I'm going to open up all these different items, and if you want to, you can hit pause to read them. Oops, now let's go back here. Excuse me one sec. Okay. There are three things that we're going to make as our main assumptions. Something secures the monopoly. Either you have a patent or you own all the raw materials. You can do whatever you want. You're not regulated by a government. And you charge the same price to everyone, and that's going to be important. Usually monopolies have very large fixed cost, which means the average total cost keeps coming down as quantity goes up. And in the case I'm showing here, this is called a natural monopoly. It is natural. It wouldn't make sense for society if you wanted to have 200 units of this product. It wouldn't make sense to have two firms producing 100 units each, but costing $15. Society would be much better off if you had one person making all of it, spreading out the fixed costs, and producing 200 units at $10 a unit. If fixed costs are extremely large, it might make sense to only have one company making the product. That's called a natural monopoly. All right, so again, in pure competition, the industry sets the price, then the individual firm on the left-hand side sees a flat demand curve. As much as they can produce, they can sell. Think corn farmers. But there is no single firm demand curve. Monopolists see a downward sloping demand curve. And one of the things I said in class is public service, is a monopoly on electricity, or a near monopoly, they have to lower the price if they want to sell more electricity during the summer to get people to use the air conditioners. Not going to go over the details of this slide. You need to hit pause to understand what's going on. I'll go over one line only. The first two columns are a demand curve. At a price of 172, we're not going to sell any. At a price of 162, we're going to sell one. And now, why does marginal revenue sit below demand? If we're selling 5 items, we're going to have to lower the price to 122. So when we lower the price to 122, right here, we're going to sell 5. Okay. The total revenue is $610. If we want to sell another one, we're going to have to lower the price to 112. But we can't then charge these people 122 because they'd be really upset with us. We said we're a single price monopolist. So when you sell 6 at 112, that's 672. You only bring in $62 more in cash. The price is 112 if you want to sell 6 units, but the 6th unit only brings in $62 more in cash, not 112, because you're cutting the price $10 on the 5 prior units. So 6 units here only brings in marginal revenue of 62, though the price is all the way up here at 112. Okay. Total revenue goes up as you come down the demand curve in the elastic portion. Marginal revenue is still positive and eventually gets to 0, and that's when your revenue doesn't go up anymore. I strongly encourage you, as you're watching this, hit pause to make sure you absorb the concepts as I'm going over them. So the question is, how much should a monopolist produce? For any of our businesses, the optimal place to be is where marginal revenue equals marginal cost. Wouldn't make sense to stop at 4 units because the marginal revenue is greater than the marginal cost. You keep going till you get to the intersection. Wouldn't make sense to go past that because the marginal cost is above marginal revenue. But then we have to figure out, are we making a profit? So let's follow this line and see where the price is. Now remember, price is always on the demand curve. Every single point on the demand curve, we have quantity on the x-axis and price on the y-axis. So if we're going to produce the quantity little m of a monopolist, the price is determined by the demand curve. Now, for this monopolist, it turns out that the average total cost to produce QM, that average total cost is down here on the average total cost curve. They're making this profit in addition to a normal profit. This is an economic profit. The price they're going to charge from the demand curve is 122. For all the models, the profit equation is P minus AT. This is your profit per unit times the number of units. And in this example, we've got 122 minus 94 times 5 is 140. Now, monopolists don't have to make money. What if the average total cost curve was way up here? Then the average total cost per unit would be above the price. And there are many examples where monopolists sell below cost to try and get rid of competition. Are monopolies efficient? In pure competition, we're going to produce in the market where supply and demand meet. We maximize the consumer surplus, which means we're allocating the right amount of resources as a society. But for a monopoly, look at the Q over here, that's QC, the quantity of a competitive market. We're going to produce where supply, which is marginal cost, equals demand at point C. But a monopolist produces where marginal revenue and marginal cost meet. The price of the product is way above the marginal cost. We're not making enough. We're losing all of this extra consumer surplus and producer surplus. That's called deadweight loss. We are not allocatively efficient. In addition, we're also not productively efficient. I don't have the minimum average total cost here. I don't have the average total cost curve on the right. but we're not producing that because the minimum average total cost occurs, the minimum average total cost is going to be wherever the marginal cost curve cuts it, but we're not going to be doing that because we're going to produce at QM, so the price B will be way above the minimum average total cost. In addition, monopolies, ceteris paribus, they don't have to be efficient. We call this inefficiency, this inherent inefficiency, X inefficiency at any point. We should be at the red line for average total cost curve, but we're not because we don't have competition. We don't have to squeeze out the last bit of efficiency in the production process. This graph will appear on the quiz and maybe even on the final. So what do we got? We got prices and we have quantity. We have 3 different points on the demand curve, representing 3 possible prices for monopoly. If the monopolists could do whatever they want, QM, where marginal revenue and marginal cost meet, and notice this marginal cost keeps going down, 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 down. They have a very big fixed cost, so the marginal cost is coming down as you're dividing that fixed cost by more and more units. Monopolists would want to produce where marginal cost and marginal revenue meet, but the price is up at the demand curve. All the things being equal, the monopolist would set the monopoly price above where marginal cost and marginal revenue meet. But if we wanted a quote-unquote fair return, well, a fair return that a lot of regulated utilities are allowed to earn, that's where the price from the demand curve is set equal to average total cost. So the intersection of demand and average total cost, which includes a normal profit, will result in a fair quantity and a fair return, including a normal profit. But we're still not where supply and demand meet. Remember, marginal cost is the supply curve. Point R would be the intersection of supply and demand, and that would be the socially optimal price, where demand crosses the marginal cost curve. We would then maximize this consumer surplus. I'm not going to go over this calculation here. It's going to do 2 points. This is a demand curve for a monopolist. If they want to sell 1 unit, they charge 7. Want to sell 1 unit, they charge 7. If they want to sell 3 units, they charge 5. 3 units, they charge 5. Here we see the downward sloping demand curve. But now, if they go from selling 2 units at 6, and they want to sell 3 units, they got to lower the price to 5. When they sold 2 units at 6, they took in $12. If they lower the price to 5, they'll sell 3 units, but only bring in an additional 3. Third unit only brings in $3. Third unit only brings in 3. Whoops, wrong color. Third unit brings in 3. Again, you sold it at 5, but you only have $3 more in the cash register because you had to cut the price $1 on these 2 units. You can't take some customers and take advantage of them. Marginal revenue sits below cost for that reason. Marginal revenue sits below demand for that reason. Let's take a look at a couple of questions. One defining characteristic of a monopolist: you've got a product with no close substitutes. If you had a substitute, then you would have competition. So they don't have any close substitutes. The pure monopoly, what can we say about the demand curve? It's downward sloping. They have to lower the price to sell more. A non-discriminating means they charge the same price to everybody. Pure monopolist must decrease price on all units of a product sold in order to sell more units. That's why marginal revenue is less than price. By the way, as I'm going over these, please hit pause after I read the question. Try and figure it out, then hit play. Many people believe that monopolies charge any price they want to without affecting sales. Let's spell the word "the" correctly. Monopolies do best when which of the following is true? What is going to be optimal performance for a monopoly? Where marginal cost and marginal revenue meet. What quantity will this monopolist produce? We want to be where marginal cost and marginal revenue meet. We want to be right there, which means they're going to produce quantity V. Now for the bonus question. What price will they charge? Well, they're going to produce V, which means they can charge all the way up at J. Then for another bonus question, are they earning an economic profit? Are they earning an economic profit? The answer is yes, because the average total cost, let's pick up a red pen, is right here. The price that they're charging is this much above their average total cost. This rectangle represents extra economic profit. Monopolies are allocatively inefficient. They're not making enough because the price on the demand curve is way above the marginal cost. People value the product more than it costs society to make. We should make more of it. Price is greater than marginal cost. And finally, monopoly is productively inefficient because the average total cost is not at the minimum. All right, then we turned our attention to monopolistic competition. We looked at a business like casual dining. They charge slightly different prices for slightly different products, but it's still relatively easy to enter and exit. As a result, because we have competition, but we have different products, we have a downward sloping demand curve. It's not as steep as a monopolist. If we raise prices, we're going to lose a lot of business because people go from Chili's to Fridays. Once again, very similar analysis. Where do we want to be? Where marginal cost and marginal revenue meet. But then the demand curve determines the price. Oops. The demand curve determines the price. The price comes from demand, but your total cost comes from your total cost curve, resulting in an economic profit for this person because the price from the demand curve is above total cost. All right, in the long run, let's say we've got a bunch of competitors and this is the situation. Is this person are these competitors making an economic profit? Well, the answer is yes, because the price is above average total cost. Let's say Chili's is making money and Fridays is making money. The word's going to get out because the invisible hand is very powerful, right? What's going to happen? An Applebee's is going to open up in between them, another restaurant. So what's going to happen to the demand at Chili's or Fridays? It's going to decline until it just touches the average total cost curve. Let's say this is the situation for a bunch of competitors in a monopolistically competitive business. Are they making money? Nope. These guys are losing money because the price up here, the average total cost, my mistake, the average total cost is above the price. Average total cost is above the price down here. Well, this is a situation that can't last forever. You can't lose money all the time. Someone's going to leave the business, and when they do, demand will rise for everybody else. Again, until it just touches the average total cost curve. Similar to, but not identical to, the long-run adjustment process in pure competition. You guys most of you people in my class are too young to remember Circuit City. It was just like Best Buy. They sold household appliances, they sold small electronics, they sold TVs. Didn't do it as well. When they went out of business, What happened to Best Buy's demand curve? It rose and they got more business. Are they efficient? This is a monopolistic competitive situation in long-run equilibrium. And how do we know that? Because we are operating at where the demand curve is just adjacent to, just tangent to the average total cost curve. The quantity that we're producing is not where supply and demand meet, which is right here. We're producing where marginal cost and marginal revenue meet. As a result, we're not getting this amount of extra consumer surplus and producer surplus, and we call that lost value to society, deadweight loss. A monopolistic competitive industry and a purely competitive industry are similar because, again, hit pause. They're similar because neither industry has significant barriers to entry. One difference between monopolistic competition and pure competition: there is some control over price in monopolistic competition. Chili's and Fridays charge different prices for their ribs. One of the examples I made in class is we all have a certain preference for different French fries. Some people like McDonald's French fries, some like Burger King French fries, people like Wendy's. And they charge slightly different prices for the fries. Assume that a monopolistically competitive industry, in this industry, firms are earning economic profits. What should happen? Well, if there's economic profits, by the way, how do we know there's economic profits? The invisible hand. Invisible hand. The word gets out. How do we know that a Fridays or a Chili's is profitable? There's a ton of cars in the parking lot. You know, if you're a regional manager for a restaurant chain and you see a busy Chili's and a busy Fridays, you're going to think there's a good place to put in a restaurant. So the word gets out there's an economic profit. What's going to happen? Other firms will enter the industry, and existing firms will see their profits shrink as their demand curve drops. Suppose some firms exit an industry. We would expect the demand curve of firms who are already there, who haven't left, those demand curves will shift to the right, which is the same thing as shifting up. Finally, this is a long-run equilibrium situation because the demand curve is just tangent to the average total cost curve. The equilibrium output, again, is going to be where marginal cost and marginal revenue at D. And then for the bonus round, what's the price? Price is always determined by the demand curve. We're going to produce where marginal cost and marginal revenue meet, and we're going to be selling at a price of A. There is no extra profits. We're going to be earning our average total cost, here, which includes a normal profit. And then finally, we come to oligopoly. Again, hit pause when you need to. When there's only a handful of producers, they've got limited control over price. Let's do another example. Name 3 companies where you can use to ship a package to Chicago. FedEx, UPS, and the United States Postal Service. Because there's so few businesses, they're constantly looking at each other. They're constantly observing what they're doing in terms of service and price. As a result, we say this kind of behavior is, for oligopolies, mutually interdependent. They're much more dependent on each other than other businesses because there's so few. If you're a big shipper, let's say you're Best Buy, and you're shipping 5,000 packages a day, you're constantly looking for the best deals, so FedEx and UPS know that people can be looking at their competitors. We talk about strategic behavior. Here an example, we have Rare Air and Uptown are 2 companies in the same business. Let's say they initially start out charging high prices. They're each going to earn $12 million. But what happens if Rare Air, and all the blue triangles are the return to Rare Air, If Rare Air decides to cut prices a little bit, lower their prices, not a lot, lower their prices a little bit, they're going to steal a lot of business, still be profitable, and they're going to raise their return to 15, causing Uptown to go from 12 to 6. But what happens if we start here and Uptown decides to cut prices a little bit? They're going to get 15, and Rare Air is going to get 6. If they're both charging high prices, they both have an incentive to lower prices to try and beat out the competition, which means we could end up here where both are earning less because they both cut prices to try and get more business. All right, in a collusive oligopoly, let me move this to the front. That means companies are talking to each other illegally. There'll be one demand curve and a marginal revenue will sit below. It'll look just like a monopoly because they're collusive. There's 3 players. They're all raising and lowering prices together. But what happens if instead of a collusive oligopoly, we now have a non-collusive oligopoly, where all of a sudden one person says, I'm going to try and steal business. But what's going to happen is your rivals are going to ignore your price increase. If you are let me back up a little bit. Let me start over again. Okay. Oops. This is a collusive oligopoly. Everybody's talking to each other. So you have one demand curve, which looks just like a monopoly. Then we're going to make the following assumption. If one person decides by themselves to lower prices, then every rival is going to have to match the price cut. But if you raise prices, your competitors are going to do their darndest to make sure they can ignore it and try and steal business because your price will be too high. So let's assume we start out where marginal cost and marginal revenue meet. We're going to be producing this quantity of an oligopolist. We're going to be charging a price based up on the demand curve. But now if one person raises prices, what's going to happen is they're going to dramatically cut their demand, because when they raise prices, they're going to lose a lot of business. They're not going to be able to move along the old demand curve. That old demand curve is no longer going to exist. That old demand curve is going to be gone. Let me get rid of the old demand curve. There we go. That old demand curve is going to be gone. So, and let me bring that to the front. Order to bring it to the front. Here's where we start out when everybody is colluding and working together. But if we decide to raise prices, we're going to be moving up along this curve. We think we're going to be moving up along this curve, but we're not, because we're going to cut off the top part of our demand curve and lose a lot of business. We're going to lose a ton of business here because our rivals are going to ignore the price increase and they're going to steal business. We end up with the kink demand curve of a non-collusive oligopolist, and these marginal revenue curves are corresponding to the demand curve. First, MR1 corresponds to this lower level of the demand curve. MR2 here corresponds to this portion of the demand curve. This explains why businesses are very sticky in an oligopoly. You don't want to lower prices because you're just going to move down the demand curve with everybody else because they're going to match the price cuts. You don't want to raise prices because you're going to cut off your demand. A collusive oligopoly looks just like a monopoly because you have one demand curve and everybody's going to move together. They're going to raise and lower prices together. Okay, what is a major prediction of the kink demand curve? Ceteris paribus, prices are going to be stable. Don't want to lower prices because people will match. Don't want to raise prices because you could lose a lot of business. Which of the following best describes efficiency? An oligopolist produces where marginal, wrong pen, where marginal cost and marginal revenue meet. That is not where supply and demand meet. We are not producing enough of it, and we're not going to produce at the minimum average total cost. We're going to be slightly higher. Price is greater than marginal cost. The price from the demand curve is above the marginal cost from the marginal cost curve. We are allocatively inefficient. And the price that we're charging, which should be equal to marginal cost, we should be here where we're meeting, it's not going to equal to the minimum average total cost. Remember, in pure competition, in the long run equilibrium, price equals marginal cost equals the minimum average total cost, a long run equilibrium process. Okay, you're going to see something like this. Here, delta is in pink, gamma is in white. Same concept. We start out both charging high prices. If delta decides to lower prices, they're going to steal business and make 75. If gamma decides to lower prices, they're going to steal business and get 75. They're probably both going to cheat, and we're going to end up here at 30. Where do we end up? Probably at 30 for both. They're both going to cheat. Suppose all firms in a collusive oligopoly, which means a cartel, they're all working together, have identical costs. So what can we say about the graph? Well, let's take a look first of all. Hold on. Step number 1, locate where marginal cost and marginal revenue meet. Step number 2, what's the cost based on that? And again, that's on the average total cost curve. There's your ATC. The price that we're charging, is up by the demand curve. Are they earning an economic profit? They sure are. The price, way above the average total cost. This firm is earning economic profits in addition to a normal profit. If oligopolistic firms successfully collude, which means they're going to work together, when one raises prices, they're all going to raise prices, that's like a pure monopoly. In a non-collusive, you cut off the top of the demand curve because when you raise prices, you lose a lot of business. Non-collusive oligopoly demand. Look at that kink demand curve, which corresponds to this kinked marginal revenue curve. It's because rivals ignore a price increase and they have no choice but to match a price decrease. What does mutual interdependence mean? They consider the reactions of their rivals before determining prices. They're constantly looking at each other. Okay, this wraps up this review for chapters 12, 13, and 14. We've got 2 more chapters after this. There are going to be 30 to 35 questions on the quiz. Good luck. If you have any questions, send me an email. This is Professor Fetterman. Take care.